So let's start by first explaining what is a blockchain. Well, a blockchain is just a data structure that basically provides the capabilities of a ledger. So the properties of a blockchain are essentially threefold. The first one is it provides this mechanism called consensus, which means that all the participants in the system agree on what data lives on the blockchain. Unfortunately, there's a bit of a caveat to that, and the caveat is that, in fact, they agree on everything that's on the blockchain, except perhaps the last, most recent few entries that were added to the chain. The second property is what we call persistence, and persistence basically means that once data has been added to the blockchain, it can never be removed. Yeah, and this is kind of an extremely important property of a blockchain. Once data has been added, there is no way to take it off. Now, again, there's a caveat to that as well. So this is this star property that basically says that, in fact, persistence will only hold as long as we make certain assumptions about the adversary. For example, maybe the adversary only has limited computing power. The third property that a blockchain provides is what we call liveness, which means that, in fact, anyone can add data to the blockchain, so it's not possible to prevent you from adding your own transactions to the blockchain, or it's not possible for the blockchain to get stuck so that no one can add new transactions to it. Okay, so I want you to remember these three properties: consensus, persistence, and liveness, because those are going to be fundamental properties that the blockchain as a data structure provides to us, and we're going to be building applications on top of that. I should mention, by the way, if you want to see a more formal definition of what a blockchain is, there's this nice paper from 2016 that you can take a look at, and there's a much deeper analysis of what a blockchain is and how do we argue that consensus protocols actually provide these capabilities. Okay, so now that we understand what a blockchain is, let's look at kind of the first application for a blockchain, which is a currency. Yeah. So how does a blockchain provide a currency? Well, essentially, as I said, the fact that we have consensus means that everybody agrees on the set of transactions that were already executed, which means that everybody agrees on how much money everybody has. Yeah. So all the participants in the system sort of agree on the current state of the world, in particular, how much every participant actually owns. Persistence in the context of a currency means that once a transaction has been executed, there's no way to revert to that transaction. Yeah, so in some sense, that's something that you often want of the currency system in the sense that once I pay you, there's no way for me to take the money back. Yeah, maybe you can give me the money back, but as a change to the system, there's no way for me to kind of undo a transaction that was already made. And liveness is kind of the third property, which basically means the system cannot get stuck and all of a sudden not accept any more transactions. And moreover, if a user wants to submit a transaction to the system, that he will always have the ability to do it. So no one can prevent you from spending the money that you already own. Okay, so you can see how these properties of consensus, persistence, and liveness immediately translate to providing a currency, and we'll talk more about that later on, but you already see why these kind of properties are kind of interesting on their own right. Okay, so now the question is, how do we achieve persistence? Persistence is kind of a difficult property to achieve in a computer system because a computer system can always be snapshotted, and then after some modifications have been made to the state of the system, you can always revert back to the original snapshot position. Yeah, and that would kind of undo everything that was done after the snapshot was taken. So the question is, how do we achieve persistence in a computing environment? And the answer is basically persistence is achieved by replication across many, many different parties. So in fact, the blockchain as a whole is replicated across many players. So for example, miners are the ones who write new data to the blockchain, but in addition, they also store the entire history of the blockchain locally. Okay, so the entire blockchain is replicated to all the miners in the system, the people who write data to the blockchain. End users will monitor the blockchain for data that affects themselves. So, for example, if we're implementing a currency, an end user might want to know how much money do I currently have in this currency, and to do that, they will monitor the blockchain by replicating it and looking at how much money they actually have. So again, there are ways to make this more efficient, but overall, there are end users who actually replicate the blockchain, and there are particular software applications, often called wallets, that actually can be used to say how much money each user has. Again, there are wallets that don't need to replicate the entire blockchain, but at the same time, there are definitely users who do replicate the entirety of it. And then there are service providers who do analysis of the blockchain, like just understanding the rate of transactions, understanding different aspects of the blockchain, and again, they replicate the blockchain in order to process it. Okay, so the fact that this data is replicated across so many participants makes it very difficult to revert to an old state, because essentially you would have to revert all the participants who have replicated the data on their own. So yeah, so the fact that everything is replicated means everyone can validate that all transactions, in fact, were done correctly on the blockchain. And in fact, if ever we find a transaction that's invalid, the block that contains that transaction is simply going to be dropped. Yeah, so there's no incentive to creating an invalid transaction, because anyone who validates it will just ignore it, and it's not going to propagate throughout the system. And again, we'll see more of that in just a little bit. Yeah, and the point is that consensus means essentially everybody's looking at the same data, and because they've all validated it, we know that it's the same valid data. So everybody agrees on the state of the blockchain, and presumably all the transactions that are on the blockchain are all valid under the rules of the blockchain protocol.